Now we're on to Unit 4B. And our first question has to do with simple interest. And simple interest is implies that there's no compounding. So the formula for it, the amount of return equals the principal times the quantity, 1 plus the rate of interest times the number of years. Y is the number of years. So for problem 1, we have, suppose that you invest $1,800, so the principal's $1,800 in an account that earns simple interest at an APR of 6.3%, so 0.063, and determine the accumulated balance after 5 years. So we set up the equation and we have A equals 1,800 times the quantity, 1 plus 0.063 times 5, and when we compute that we get $2,367, and we're done. So for the next question, though, we are going to compound. And so if you're compounding annually, then the formula is your accumulated amount equals the principal times 1 plus whatever the, and I should have APR there. Different books use different notations. APR raised to the Y power, the number of years. So our principal is $25,000. The approved rate is 3.4%, which is 0.034, and the number of years are 7, and we have to find the accumulated balance. So when we plug these values in, we get $25,000 times, and 1 plus 0.034 is 1.034, so we can write it in that manner, raised to the 7th power. So at the end of 7 years, that $25,000 will have grown to $31,592.48. Now for question 3. And for 3, that has to do with, in fact, let me just read it. Suppose that you invested $168 in an account that earns interest at an APR of 7%, compounded quarterly. Determine the accumulated balance after 18 years. Well, now we're compounding more than annually, more times than once a year. So if you compound quarterly, you're going to compound 4 times a year, 4 quarters in the year. So APR represents the rate, N represents the number of compoundings in the year. And this is going to be raised to the NY power. So the principal is $168. The APR is 7% or 0.07. The number of compoundings per year is 4, and the number of years is 18. And when we structure the equation, installing those values and compute, what we have is $585.85. That's what our accumulated balance is. Now keep in mind, if you're having problems with your calculator, then give me a call. I'll be happy to go over it with you. And you can say, well, you're going a little quick here. Well, you can stop anytime and back up and review what we've done. So hope it's not going too quick, given that you can back up and redo. But keep in mind, too, you have to replicate everything I'm doing so you get the feel of this. Watching me is not enough. And make sure when you enter this into the calculator, put parentheses around this exponent here. Otherwise, it'll just raise it to the fourth power and then multiply the whole thing times 18, which is not what you mean. So, now for number 4, suppose that you invest $5,178 in an account that earns interest at an APR of 4.1% compounded monthly. So N is going to be 12 because you're going to compound 12 times a year. Determine the accumulated balance after 8 years. And so P is $5,178. APR is 0.041. Number of compoundings per year is 12, and the number of years is 8. So A equals, and we'll structure our equation appropriately, and we've got 0.041 divided by 12, and then the exponent is 12 times 8, which would be 96. And when we compute that, we get $7,184.03. So finally, let's do number 5. And now number 5 has to do with the APY, the approved yield. And APY, instead of, is a simple interest rate that yields an equivalent return relative to a compounded rate. So if we were, and by the way, T, we're going to let T be 1 year. Anytime you use this, you let T be 1 year. So if it's simple interest, we have principal times 1 plus APY. And compounded, we have principal times the quantity 1 plus APR over N raised to the nth power. Now, the P's will divide out. If we divide both sides by P, they're gone. Now, so we have 1 plus APY equals the quantity 1 plus APR over N raised to the nth power. To isolate APY, we simply subtract 1 from both sides, and there's our equation for the APY, the approved yield. And that's quantity 1 plus APR over N, close the parentheses, raised to the nth power, and then from all of that we subtract 1. So our APR is 0.093 and N is 4. When we install those values into their appropriate positions and compute, we get 0.0963, which corresponds to 9.63%. Notice our APR was 9.3%. Our APY is going to be greater. It's 9.63%. So if you had a simple interest rate of 9.63%, you'd wind up getting the same yield without compounding as you would when you compound using 9.3%. And we'll go on to the next part.